Hey guys, Scanner Danner here. Today we're working on a 2009 Ford Fusion. Customer complaint is just the check engine light is on. And you can see here with the fault codes we have, we are dealing with a secondary air pump issue. So this P0410 secondary air injection system fault, and then P0491 air system insufficient flow bank 1. As far as direction and where we're going, this is an unfamiliar system to me. So I don't have a specific path right now, but a few things we can think about is it's an electric air pump. I did a quick visual inspection. I'll show you guys some of these components. All right, so the first thing I did was just look at the exhaust manifold, which is in the back, and I can see a metal tube. It runs over this way. That is my air pump line. That would be this guy right here. Then that goes underneath right to this valve right here. This is going to be your diverter valve. It looks like it's vacuum controlled. So that line on the other side of this diverter is going to go to the air pump. So this fat line right where my finger's touching right there. That's going to go down to my air pump. To be this tube. Follow it down further. It comes around underneath, and what you can't see from the top is the air pump itself, which is underneath the intake manifold. So it is an electric air pump. And then I see another part of the system that we want to focus on. This vacuum line comes over here to a solenoid, computer controlled solenoid. So that's what we're using to open up this diverter, is we're applying vacuum to it. And so pretty straightforward system. I think step one is going to be see what kind of bidirectional controls I have of this pump. We'll do some key on engine off test, see if we can energize the pump, just listen to it. Then maybe from there we'll do a running test if it lets us, and we will watch the oxygen sensor signals while we turn the air pump on. So that's the plan for me. You know, without looking at the flow chart, wiring diagram, and things like that, I want to try to attack this just off of common knowledge first. So by common knowledge, I'm talking about an electric air pump that's either power or ground side controlled. Talking about an electronic solenoid that is the same, either power or ground side controlled. Then we have some vacuum lines we need to look at, some plumbing. Pretty straightforward system, to be honest with you. All right, so functional tests, output controls. That's gonna suck if they don't give me an option to bidirectionally control this. I'm not gonna be happy. Looks like they're not. In light of that, I think what I'm going to do is go right to the relay if I can find it easily without a diagram. This being a Ford, that's not going to happen because Ford doesn't label their fuse panels. Stupid Fords. So it's not like I'm going to be able to go to this guy and know which one my relay is for my secondary air injection pump. Man, a bidirectional control would be very, very helpful to me right now. What are my options? Let's see if we can get online here. See if I'm close enough to Wi-Fi. I'm gonna have to get a diagram. I was hoping to do this a little bit more simply, but it's time to look at a diagram. So we got a designated secondary air pump relay, and a designated fuse. No, that feeds. The same time the air pump gets power, it's also feeding fuse 45, which is a 5 amp. I bet you that goes down to the solenoid. That's on 20. Gray with a red. Oh, that's a monitored circuit. So that'd be a pull-up type switch input. For those of you following along, that'd be my chapter 2 material. So that's just the computer monitoring that circuit. So from the relay, when that relay powers up from fuse 7, it's a 40 amp, comes through pin 87 or pin 30 to pin 87, powers up this gray and yellow circuit, branches off, goes to fuse 45, which is a 5 amp, and that is the circuit the computer's watching to make sure that the relay actually latched and is sending power to the pump. So the same time on the gray yellow circuit that we're powering the pump is the same time we're feeding fuse 45 in a pull up fashion. It's a switch input in a sense, monitored circuit. When the computer sees 12 volts on the gray red wire, it says cool, the relay latched, and the pump should be running. And then it's going to do other tests on it as well. All right, let me look at this solenoid now. Let's figure out how the solenoid's controlled. Solenoid, secondary air pump solenoid. So we follow the wires, follow both. And we'll start with the splice on the violet gray. It is shared with the relay. So that's probably going to be a power is my guess. Could be a ground. Let's follow the violet gray. That goes to 4. 4 violet gray comes over to my computer SAIR, secondary air. That's pin 1. So that's the computer wire. Still doesn't answer our question. This is chapter 3 material, by the way. Stuff I teach every day in my classes. So what we want to do is, in my text, I say follow the wire. We're trying to figure out how this thing's controlled. Follow the wire that doesn't go to the computer. We'll tell you what's in the computer. So we know the violet gray wire, pin 2, goes to the computer. There's another, that's weird that they use the same color. Wonder if that's a misprint. Pin 1, violet gray on pin 1, comes down to 4 on the diagram. We'll go to the next page. Violet gray 4. Following it across goes to violet gray 3. Next page again, violet gray on 3 comes across the page to violet gray on 6. 6 comes to a splice that's shared with every other violet gray wire on this car. Yeah, and I'm just following one of the wires. It goes over to the computer on pin 20, says VE power, that's or VB power. That's a battery feed. That's feeding into the computer. That splice, that's a main. That is a main power feed. Yeah, all of these are using it. The dotted line comes down the page over here on the left. So S109, follow that. We'll go down this dotted line. Also ties in on the violet gray at the bottom. So the variable camshaft timing solenoid uses it. The O2 heaters are using it. That is going to be a power feed, and so that means that, let's go back. Well, some of you guys probably want to know where that power feed is coming from. It's going to be a relay or something. It's just not on this page. We have to go back. This is a little bit difficult to do on a screen like this and have you guys follow what I'm doing. All these violet gray wires are on the same circuit. You see the cam sensors using it too. Intake manifold runner control is using it. So pin 2 and 3, not pin, sorry, diagram number 2 and 3. Next page. 2 and 3 goes 3 and 4. Three and 4, there's my air pump solenoid, and 3. Goes over to 5. It's going to be the power relay, you watch. PCM power relay. Yeah, big splice right there. So 1, 2, and 5 on this comes from fuse 49, and fuse 49 is going to be powered up by the PCM power relay. So all of that to say that that solenoid is ground side controlled by the engine computer. So if the PCM power relay is powering up all of those circuits, including, let's go back to my secondary air injection solenoid, including pin 1 on the secondary air pump solenoid, that means pin 2 that goes to the computer is a ground side controlled circuit. All right, so we're talking manual controls here, and here's what I'm thinking about. I want to make sure my pump runs. Amperage is going to be a factor, maybe. We want to make sure that the O2s react if the pump runs. We also want to make sure that we can open this secondary air pump solenoid to feed vacuum through to the diverter to make the valve open and pump air into the exhaust and watch the O2. So that's the process we're going to go through. I think the first thing I want to do is I want to energize this secondary air pump circuit, and that's going to involve this relay. And nice of Ford again to not give me a number even on this diagram. So I got to switch diagrams because they're not giving me a number unless they're abbreviating it here. They are not. This is just simply numbers. Numbers. No, we can use the owner's manual. Stupid Fords. Secondary air pump relay. Should be this bottom guy right here, that relay, for whatever reason, is different than all the other ones. So it looks like that relay was maybe replaced before. Just the fact that it's different than the others, maybe not. I mean, it could be. Just design. I mean, on the diagram, they're showing that as a 4-pin, so it is a Ford relay. Well, that's a heavy duty bad boy, huh? Cool. Should still be able to use my U-Activate kit. So even though my pins are a lot bigger, the load side ones, I still should be able to use this kit. Those are my load control. Sweet. Love this tool. I heard the pump run. Didn't mean to have the switch on. Listen. Sure sounds like the pump's in a different location than what our visual inspection showed. But maybe just because I'm hearing it. Looks like it's pumping into the air filter housing. Pretty sweet tool, huh? Well, that's cool. The pump runs. I need to follow my plumbing here because I'm hearing air in a location I did not expect. Yeah, it's definitely dumping into the, or that's the air inlet maybe for the pump. Okay, so this tube is the inlet. That's why I'm hearing it so loudly in here. Well, that's not good either. This being loose. That's not going to set an air pump code, but let's get this out of the way. Let's see if I can feel the inlet of that. Yeah, so that's my inlet tube for the pump. And then my discharge way up here. Okay, so pump runs, we hear it. That doesn't tell me my flow's right, doesn't tell me my amperage is good. We can do an amperage measurement with this tool too, but I'll save that for later. We'll put an amp clamp on here if everything else tests good. But what we need to check now, well, unfortunately, I'm not testing this relay. I'm bypassing the relay. So if the relay is a high failure item, we really need to check this too. And I don't like using an ohm meter. I want to put at least some kind of a load on this. And what I can do, all right, so this is something really anybody can do, but you need to know what you're doing, because if you do something like this wrong, what I'm about to show you, you have the potential of damaging the computer driver for this relay. Okay, anytime you're doing tests like this that involve jumping a circuit, which is what I'm going to show you. I only need one strand of this copper wire. I'm just going to check this relay under a load. Remember, this is power side fed, ground side switched. So I'm going to go to ground with my test light. Check my test light, make sure it lights. My two control pins, this one and this one. See the one that's lit brightly? That's going to be my feed to my relay. And then the one that's glowing dimly, some type of bias voltage on that circuit probably, that's going to be my control pin right there. So what I'm going to do is being careful that this wire, once I get this in place, doesn't touch anything else, especially these other pins on the relay. That's where we get in trouble. We're just going to do a relay check. Is the plan. A lot of guys will want to, you know, maybe energize the relay and then use an ohm meter. So you can energize these two pins with jumper wires and then use an ohm meter between these two pins. And it should be infinity open when these are not energized. And when these two are energized, the coil closes the switch, and then those two should show 0 ohms. I don't like that test. So relay installed. My test light's going to be my tool that I'm going to use to energize this. This should click the relay and run the pump. Hope you guys followed what I just did. Okay. Now I'm not applying a full ground to the relay. There is the test light resistance in there, but it's enough. This is a 200 milliamp test light. And the control side of a relay is typically around 100 milliamps. So there's enough, even though there's some resistance in the bulb, there's enough of a ground to give this a magnetic field. Close the contacts of the relay, run the pump. All right, so we just checked the relay too. Again, my bypass tool substitutes the relay. Okay, so from this point, we're going to plug my bypass tool back in. There's some other things. We're really not done with the relay yet either, because we never checked the computer control of the relay. All we've done is test the relay. In my test, I was actually being the computer. I was doing what the computer would do and grounding that pin. So I'm not checking the computer control of the relay or the driver. And that's where our bidirectional test would come in. Unfortunately, I don't have a bidirectional test, so I'm moving away from that right now. We'll come back to that if we need to. We need to check these other components. I still have to check the solenoid and the diverter and make sure they're working. So that's what's next. The next one's going to be this solenoid. We want to make sure this solenoid can supply vacuum to that valve. And I think for you guys, let me get a vacuum gauge. Okay, so vacuum to this diverter that I just unplugged is going to come from the solenoid right here. And it has a vacuum supply, so I haven't eyeballed that yet. I should have maybe even started with that. Let's eyeball this vacuum supply line. That is this one. Goes under the manifold. It's still connected, not broken. Okay. What we want is I want vacuum to go to this valve whenever we start the car and I energize this solenoid. Now, we're at a relatively cold engine temperature right now, and it is possible that we are meeting the conditions to run the air pump right now. So maybe just starting it up. Let me just say this. Well, I gotta put this back on too because of the mass airflow. And you know what? We better tighten that. That was loose. I'll get a real screwdriver here in a minute. But somebody left that air tube loose. Anyway, what I was getting at, if I start this and that vacuum gauge moves, that means the air pump was being commanded on. We can actually watch the LED light on this too, which is the control side of my relay. That'll tell us if the computer is actually turning that air pump on. Because I have the relay out, so it's not gonna turn on with my tool in here, but let me start it and then I'll talk about it. All right, yeah, so there we go. See the pump commanded on, see the vacuum. So that air pump was just commanded on, now it just shut off. That was awesome. That told me a whole bunch of stuff right there. That test alone. So I was gonna manually energize this coil here. In fact, I'll do that too, just because. Let's do it. But that test, when we saw that LED light, there it is again. That air pump's being turned on. Okay, you know what? Hold on. I need to change direction again. Just because I have this window of opportunity, I put the relay back in. This is not in the equation anymore. What I want to do, because now I'm seeing vacuum here, is I'm going to start it and then I'm going to pull this off when I hear the pump running, because I want to hear a pitch change. If this doesn't change pitch, that means my diverter's stuck shut. Okay, so I'm going to try it. There's no change. Now I could hear the diaphragm part working, but I did not hear an airflow change on the discharge side of this diverter. And so what that means is our diverter's bad. Let me take this hose off on the back. Let me get this hose off and I'll show you guys where I am. It's the discharge side of this diverter valve. Okay. Now at this point, if I want to do this with the car off, I would want to manually energize the relay, manually energize the solenoid. I would need a vacuum supply there too. So let's try this again. With the car running, and then I'll figure out a way to teach you guys how to do it if you did not have a system like I'm dealing with right now, where it's cold enough that you can use the car to do these checks. No airflow at all. One more time. What we want, I did that backwards. I heard the air pump run. Can you see this tube? This tube right here. Put my thumb over the hole, there was no airflow. And I know we have vacuum to this, I showed it to you guys. Pulling vacuum off would close it, putting vacuum back to it would open it. One more time, I'm going to start it, see if we get this air pump to turn on. No airflow at all, none whatsoever on that tube. Let's see if I can unstick this thing. Nope. Okay, so I am pretty confident that this diverter's bad, but there's one more piece that I need to make sure of, and that's I don't have a restriction from the pump up to here. So what I need to do is take the inlet side off of this diverter and make sure that I have airflow here. And then we'll talk about the test that I was doing. So that's my inlet to the diverter. All kinds of airflow. Cool. So I hope that makes sense on what I showed you. I mean, we're pretty much done with the car. It definitely needs a diverter valve. I just want to review a few of the steps that we took, and then I think what I'd like to do is show you guys how to manually activate these circuits and check that flow the way we just did. I might need, well, there's multiple ways we can do it with the vacuum part. A hand vacuum pump would work. We can use the existing vacuum. Using the solenoid, we'd have to have the car running, energize the coil, and then manually energize the relay. So it was very valuable, very, very valuable to us that this car was at a colder temperature that was allowing us to use the computer's control of the pump and then check the circuits involved. Now, if this was a hot engine without bidirectional controls, I'm pretty confident that this air pump does not run on hot restarts, and so you'd have to let the car cool off. There would be no way that you could check the computer's control of the relay, the final part when we did the relay test that I told you we couldn't test, without having that driver turn on. So there's two ways to turn a driver on. One, bidirectional controls. Well, we didn't have them available. So two is to meet the conditions that the driver needs to turn on. That's the only other way to check it. So we'd have a driver issue, we would still need to check. We would have a wiring integrity between the driver and the computer and the relay, okay? So there'd be that part of the circuit. Of course, you have the pump itself, powers and grounds to the pump. Does it run? You know, we're kind of doing the relay and the pump together. And then it comes up to the diverter, and the diverter is vacuum controlled. So we have a solenoid. We did our checks on the diagram. We found out it was power fed and ground side switched. We're going to review that here in a minute because I'm going to show you how to energize that solenoid. Same way I showed you how to energize the relay. So the solenoid's a factor, and let's say that the solenoid worked and you could make it work. You could make airflow go to the diverter, and the diverter worked and you had air going to the exhaust. Well, consider that the computer also controls the solenoid. So you have to have that driver. There's two drivers. There's a driver for the relay, there's a driver for the solenoid. So you have to make sure the driver for the solenoid can function. And again, if you don't have bidirectional controls, how do you test that? You have to meet the conditions for that driver to turn on, which is the same time the air pump runs. So you need the engine cold on a startup. That would be how you check the solenoid driver. Fortunately for us, because of the way things went, we had a vacuum gauge on the diverter telling us that the vacuum switching solenoid or valve works and applies vacuum to the diverter. It also told us the computer driver was good. It also told us the computer driver control wire, the integrity of the wiring from computer to solenoid was good. Same thing with the relay. So pretty sweet that we have the vacuum gauge there, that you guys could see that. Diverter valve stuck shut. How do you check for a stuck shut diverter? You need to have air going to the diverter. Then you need to apply, in this case, vacuum to the diverter to make it open, and then you check air on the other side. No vacuum, no air. You have vacuum, you should have air. So that's the last part that I can show you guys manually, which isn't necessary. We're done. This needs a diverter. It's stuck shut. But those are just things you need to think about. If you have an air pump fault that is intermittent, or you just have an air pump fault and you're going through the system and everything checks out fine, don't forget about your drivers. You got to make sure those drivers turn on. Don't forget about your control wires. There's 2 of them, one to the relay, one to the solenoid. And then the final piece, if it got that far, I didn't know how far this was going to take us, but the final piece would be the oxygen sensors and making sure that those O2 signals drop lean with that air pump being turned on. So that's another piece to this equation too. Let me show you the test on the solenoid and the diverter, and then we should be done. All right, now as with anything, everything we do, there are multiple checks that we can do on the same system. So one of the things that I could do is I could do with the engine off, I could take a hand vacuum pump to where this line goes on the port behind here. You probably can't see it, it's blocked by this bracket. On the diverter itself, and then pump it up while I'm energizing the air pump with my tool. That would be the test that we could use. But let's say you don't have a hand vacuum pump, and right now I don't have a hand vacuum pump with me. Let's do some fundamental tests on the solenoid. We can shortcut this a little bit. So test lights, battery, ground. I'm going to back probe this. I know it's ground side controlled. Is that tied in? Is that the same driver? Did I miss that in the diagram? The fact that that shouldn't be energizing the relay unless it's a shared control circuit for the relay, and I didn't see that. I need to look at the diagram again, because I was surprised that that happened. Well, we've definitely identified the control wire. So they're using one driver in the computer and they're not showing me that. It's definitely a variable here, and that makes sense on why my relay had a glow to it. It wasn't a bias, it's a shared circuit. Here, I'll show you. I don't even need to see it on the diagram. I'll maybe be able to show you that, but watch this. So if you remember, when we were doing our circuit analysis on the relay, circuit design, this pin to the right, yep, just heard that solenoid energize. I'm energizing that solenoid right now. That test light's glowing dimly. Watch when I unplug the solenoid, that test light's going to go out. So that's not a bias voltage, that's a shared ground. The relay shares a ground with the solenoid. That means there's only one driver. Watch, I'll unplug the solenoid. Watch my test light go out. Let me get my hands out of the way. Watch that test light go out as soon as I do this. There you go. Shared circuit. Relay and solenoid use one driver, so I don't even care what the wiring diagram shows me. Even if it shows that as a separate circuit, there is one driver in the computer. Let's follow it. Oh, they do show it, and I missed it. Totally blew past it. Check it out. Violet gray on pin 2. That guy right there, shared. Totally blew past it when we first went through this diagram. Shared circuit, one driver. That's why when I'm taking and I'm back probing pin 2 on the solenoid. I'm providing a partial ground to the solenoid, and I am also providing a partial ground to the relay coil, which is enough to energize the coil and make it do its thing. That's pretty cool. That's pretty cool. All right, so relay back in. This is not typical. You'd have to energize two different circuits. In my case though, I can energize it here. Now the question is that enough of a magnetic field for the solenoid to do its job and transfer vacuum? Let's make sure. I'm going to start the car. We'll see if this test, my test light carries enough current. We'll let that do its thing first. All right, that was the computer doing it. Now here's me doing it. Now why would that? I wonder why that made it rough. Oh, I know why. Because I'm turning the air pump on the same time the inlet for the air pump's behind the mass airflow sensor, and I'm doing it at a time where the computer's not ready for it. So I've just changed the airflow characteristics in the manifold. That's why it idles funny like that. I bet you in a default strategy, I'm just playing right now. I'm gonna unplug the MAF and let this run in a default strategy. Come on. Come on. Come on. You know your MAF's unplugged. Get with the program. All right. I bet you it doesn't do it now. Cool. Hope that makes sense on why me manually energizing that was affecting the way the car was running. Again, air inlet for the MAF, and I'm doing it at a time where it shouldn't be. Okay? Pretty cool stuff. All right, watch. My hand. Okay. So I'm gonna plug this back in. We know our airflow is good here. Okay. Let's see if we can free up this diverter too. Probably not. Well, I hope you learned something from that. I know a lot of you guys that have been following me for a long time followed that perfectly. For some of you guys that maybe are finding me for the first time, you might be a little bit confused and have some questions. And everything that I did with this unfamiliar system revolves around fundamentals: power, ground side switching, drivers, control circuits, relays, how to test them. I'd mentioned bias voltage, and what's bias voltage? Well, that voltage on my test light over there wasn't a bias, it was tied into the solenoid. Solenoid controls, normally open, normally closed. How's the computer controlling it? And then the vacuum supply, how was the vacuum? The pump itself, all foundational, fundamental material. For you guys that are interested, chapters 2 and 3 in my textbook. I've written a textbook. It's a field manual. to allow you to get up to speed with this kind of stuff. It's available from my website, scannerdanner.com. I also have a program that I've developed. It's called Scanner Danner Premium, that I can bring you into my classroom at Rosedale Technical College. And I essentially am teaching you through my book, page for page through the book, fundamentals, how to do this stuff, and where we take the theory part of this, or the field part of this, and then we apply the theory behind it. And then when you come back and you start doing field work, you can just go right through it like you guys just watched. Unfamiliar system. I've never worked on one of these. Not the air pump system on this design, this year model Ford. But it was nothing I couldn't handle. I didn't have to follow the flow chart. The wiring diagram was helpful for sure. We needed some service information, but I didn't have to follow a manufacturer flow chart, and I knew exactly what I was doing. So look forward to hearing your questions on this. I know there's probably many. I'll do my best to answer them. I hope I clarified the tests that I was doing good enough for you. I guess I'll find out in the edits. If I did, that's the magic of editing. I can put arrows and notes and things like that, but I think I did an okay job. It helps to have my son, Caleb, here with me, who's still in school, because he asked me a bunch of good questions that you guys have the same questions of, and he's not here, so I am by myself talking to a camera. But again, fundamentals, guys, that's what this is about. Check out my website, scannerdanner.com. Scanner Danner Premium has a 14-day free trial. Check it out. You guys owe it to yourself. Even if you sign up and then unsubscribe before the 14 days are up, you won't be charged a dime. Just look and see what is there. There's 400 plus videos on there right now, with 200 or so being classroom lectures and hundreds of hours of training material where I'm just teaching foundational stuff like this. Thank you, guys. I'll see you next time. Okay, guys, I have a little bonus footage here. Sorry for the mic change. Might sound a little bit different with the audio. I have the diverter out of that car. I apologize I didn't get to show you the new one in there. I didn't think it was really necessary. As I showed, there was no airflow out of this at all, and it was this side you guys couldn't really see in the captures. Right, this was the side that went to the exhaust, and I believe, yeah, and this was the inlet from the pump. Just a couple real quick things before I take this apart. I want to at least see if we can see what failed inside of here, but I wanted to mention two things. One, the test I was doing here on the solenoid with my test light, I don't know if you guys noticed, but there were times when I was putting my test light in that you could hear the pump turn on because the relay was tied in, but you didn't see vacuum change. There was no vacuum going to the end of this tube. And the reason for that was my test light was not carrying enough current flow at times to fully energize this solenoid to make the magnetic field strong enough to open it and have vacuum go through. You could see when I first put the test light in, it would, because the bulb was cold, and so there's a little bit more current flow at that point in time. And then if I held it on there, or pulled it out, put it right back in while the bulb was hot, you could see that there was no vacuum there. So I just wanted to warn you guys, as I was choosing that method with my test light, and then I was banging on the valve to try to free it up, I was thinking I had vacuum there the whole time, and I may have, but I may not have. And so that's a variable I wanted to point out. I missed that in the filming of this, but I saw it in the edits. So it has to do with current flow. And in a situation like that, what would you do if you needed to energize the valve and the test light wasn't doing it properly? In other words, it was enough. This was a little confusing because of the relay, but it was enough to energize the relay, but not the solenoid and relay at the same time. And solenoid sometimes need a little bit more current flow than what your test light provides, so you need to use a jumper wire. Just want to caution you on jumper wires. We could hurt things if we do it wrong. So chapter 3 material, again, we talk about the warnings with jumper wires and test lights and current flow and all of that. So, all right, enough of that. One more piece. In this clip, you can see where I wrap the wire around the pin of the relay. I want to caution you guys on this too. And again, This is chapter 3 material. I talk about this. There's some safety issues here. Now, this being a ground side switch solenoid, if this wire that I have hanging out here would have touched something metal on the body of the car, it wouldn't have hurt anything. It would have just energized the relay. No harm, no foul. However, if this relay was a power side switch circuit and I have that wire there and it touches ground at the same time the computer was energizing the circuit, I would cook the computer driver. I hope that's clear. Power side switch circuit, if the driver's on, computer sending power down the line on the control wire, and I have the control wire modified in a way that I can manipulate it. If that copper wire would touch ground on a power side switch circuit, you would cook the engine computer. On a ground side switch circuit, not the case. Touches ground, we just energize the relay. If the computer happened to already be energizing the relay, giving it a ground, we would just be giving it another ground. Again, we wouldn't hurt the circuit. So I wanted to point that out. Jumping relays can be very dangerous, and you guys just need to be aware of that. Again, all stuff that I cover in my classes. All right, let's see if we can get this thing apart in one piece, and maybe, if we're lucky, show you guys what failed inside of it. Something else I wanted to mention here, maybe while I'm taking this apart. I had mentioned about the oxygen sensors and seeing if they would change properly, and I didn't elaborate on that if they did not. So let's say we did all of our checks and we still have this air pump code. You can have an air pump that's not producing enough airflow, and that was where that comment came in about the oxygen sensors and how lean they would get and how much the fuel trims change and what the strategy is there. So that was that comment. Okay, that's just a gasket, high temperature. And what's on this side? I still need to be careful. Don't know what all is in here. That's me pulling a vacuum on that. Still have sound but no movement here. Let's see what else is in here. I feel like that should come apart a little bit more without taking the other side apart. I also know that the diaphragm part didn't fail because I could hear the movement, and it would move and then it would spring back when I'd let go of the vacuum. So there's something mechanically stuck in here for sure. There's our spring. Spring and diaphragm, high temperature, so it would pull. But nothing opens on this side. It's like something broken in there. metal disc. You see the disc inside, and that disc that you're seeing in that hole is actually a metal disc. So that should move, and we should be able to push air. See, this was the exhaust side. Air was coming in from the other side. Even though that piece is moved and it's in on the inside, this outer piece is still in place. It feels like it's stuck. Yep. Okay. Spring is broken. Look, there's a spring there. Is it this check valve? Is this the part that failed? I don't know what this spring does. Why is it there? I gotta go look. Airflow was pushing in this way, so that makes a little bit more sense to me on how this works. So air would push in on this, so it would not have been attached to this. I don't know what the spring does just yet, but airflow would definitely have been in this direction, pushing on this piece, and then the valve would open, right, and then allow air flow through. Now I heard the valve moving. You could hear it when I was applying and releasing vacuum to it. So I don't know exactly what failed. Cool. Yes, it's growing. The new nail's growing in. There's no question it's coming off. You're fine. Here, you want to show everyone on camera what your finger looks like?
It's gonna be weird.
Alright. Yeah, stick your finger right here. Yeah, I was just talking to my daughter May. Put your finger right there. May got her finger slammed in a door. Broke the tip of her finger. She's about to lose her fingernail and she's freaking out about it. Go to bed, sweetie. Love you.
I'm gonna throw up. There's like a
You're
hole
fine.
in my finger.
You're fine. So what failed? I heard it moving. I know it fixed the car. You guys saw in the footage that there were no leaves on the trees. This was filmed months ago. This car was a fix, for sure. I proved the flow issue, but I heard it clicking. I heard it moving. I have Caleb helping me. He's graduated from school now. In the footage I said that he's still in school, but he's graduated now, and I have him back. He's working for me now a lot more hours, so we hope to produce you guys a lot more videos here coming up, both on YouTube and on the premium channel. I don't see anything wrong with the valve. Airflow should push that, and it was not able to. I wonder if it was mechanically stuck, and the part that I was hearing maybe would have been, well, I can't simulate it now, but pulling a vacuum here, that essentially I was hearing the diaphragm just kind of pull up and then snap back, and it was never really moving. because this is definitely, I moved it a bunch now, but this is definitely it's sticky. It could be just as simple as that. Yeah, what I was hearing was the diaphragm flex and then release, and not a full movement of this valve. I mean, that's the only thing the only way I can explain for this not to work is it was stuck. And I wonder if I could have beat on it some more, could have unstuck it. Well, I was hoping for some hard evidence inside. I have none, but it is real tight at times. It should be. Oh yeah. Damn, I was hoping for some real good camera footage of a stuck valve, and I just not happy about that. Don't know exactly what this spring would do on the end of this. I'm not totally sure. Maybe keep it from fluttering. Well, some bonus footage that all that's going to do is make you guys question me on my repair. But I promise you the vehicle is fixed. And has to be that this valve is sticking. And the clicking I was hearing was maybe partial movement or just the diaphragm flexing and releasing. No other explanation for that. Alright,